Hola y guten Tag. My name is Nils. I'm a student at the University of Leipzig studying data science for my master's there, and I can't attend the Worms Workshop 2021. So this is my presentation. I hope you have fun. I hope you give me some feedback afterwards. Let me know. I'm glad to be here on this way. Hasta luego.
Hello, let's dive right into it. I present you my paper, Implementation and Evaluation of a Neural Network for the Recognition of Handwritten Melodies. This paper was written as part of my bachelor thesis. Accordingly, this is an abbreviated version of this work. The conducted work has been supervised by Junior Professor Manuel Burkhardt at the University of Leipzig in the field of digital humanities. Let's move on to the outline. So, first of all, I present the data used, then I show the architecture used and how the data was prepared for this architecture. That means my workflow. And finally, I will show you the results I've obtained with this architecture and workflow. All right, let's move on to the data. The data come from Regensburg, to be more exact, the University Library of Regensburg, which has been responsible for several extensive collections and folk music research sources. These have been handed down orally or handwritten over the years, and a large part of the folk song collection dates back to 1914. In previous research, these collections, 3 of them, were digitized and were made accessible to the public through a platform created especially for this purpose, the Regensburg Volksmusikportal. The Regensburger Volksmusikportal consists of 3 collections, the Liedblattsammlung Volksmusik from Südtirol and Feldforschungen by Felix Hörburger. This Liedblattsammlung, the Regenburger Liedblattsammlung, contains of 140,000 folk sheet music pages. This collection have been the research object of previous work done by researchers as Manuel Burkhardt and his team. To name one, it's the Allegro project, where researchers tried to use crowdsourcing as the tool to obtain the melodies of the collection to make melodic search or melodic similarity analysis feasible, but it shows, unfortunately, that the extent of 140,000 sheet music pages are far beyond the financial scope of this project. So next idea was to use OMR, more especially deep learning in the OMR field, to obtain these melodies, and this is what I was doing with my work. Yeah. So now let's take a look at the example sheet music. So this is what a page from the Regensburger Liedblattsammlung looks like. On the top you've got a stuff, below that you've got German lyrics from the folk music song, down there the number of the sheet music and the origin, where it comes from. So from which archive. Alright, let's dive deep into the architecture. To explain how I came to the architecture, I have to elaborate a bit. I'm a complete newcomer to the field of deep learning and OMR. So I wrote to the person in the field who has been getting attention in OMR papers over the last few years, and Alexander Pacher answered me immediately to my luck and offered me to talk to me every Wednesday to give me some insights into the world of OMR. Meanwhile, he also referred me to Jorge Carlos Zaragoza, who was looking at a similar project at the same time, and so the recognition of monophonic melodies. And in consultation with Carlos Zaragoza, he gave me an unpublished paper of himself and his team, which he was doing at the time, a neural approach for full-page optical music recognition of mensual documents. He was doing with Francisco Castellanos and Jose y Iniesta. And I gratefully accepted his offer to help me with the implementation. So he and Francesco y Castellanos and Antonio Rios helped me with the implementation and answered a lot of my questions. Thanks to all of you guys at this point. Without you, I couldn't have done this work. All right, so let's move on. So the architecture consists of 2 steps. So on the one hand, we've got the selectional autoencoder and a convolutional recurrent neural network. So the selectional autoencoder is used to get the layout detection of the sheet music. Therefore, in the first step, it learns to encode and decode the music sheet. And here you can see the white boxes, the white rectangles, are the learned representation where the bounding boxes are for the staves. And in the second step, it extracts them for the convolutional recurrent neural network, which then learns to read the notes. The convolutional recurrent neural network is based on the end-to-end neural optical music recognition of monophonic scores by Saragossa and Rizzo. I hope I pronounced it the right way. All right, so this picture is taken by Rios, Vila et al. It shows the convolutional recurrent neural network, which then learns the alphabet, decoded the proper way with the connectionist temporal classifier. So let's go into the workflow. The workflow is the step where I prepared the data for the single architecture steps. So I need to prepare data for the selectional autoencoder to show him what are bounding boxes, what do they look like. And in the second step, I need to give a representation of the shown music to the convolutional recurrent neural network. So for the first step, I use Label IMG. Label IMG is a graphical image annotation tool, open source. You can take a look at the GitHub page for my image annotation. It worked pretty well. You can take a look here. So I've got my sheet music on the left side. I put it into the Label IMG. Then I drew some bounding boxes, and it outputs it in the XML format. This XML file then is given in the next step to the CRNN to obtain the single staves, which are then annotated with the kern format. So here you can see my screen at the time when I was annotating the kern files for the sheet music. So I take a single staff. So for this example, I took the first staff on the music page, write down the kern format manually, and put it in the Verovio Humdrum viewer to check it back for errors, play it back as audio to hear errors. And if that worked, I save it with a little script to go on to the next stuff. All right, so this is what my workflow looked like. I decided that there were a bunch of work to do for the kern annotation. That's why I went for training with the transfer learning. I chose two common datasets, I guess. The one is the camera premise dataset by Saragossa at Rizzo, and the other one is the FMT dataset. So in the next step, I wanted to see whether there's any difference between the transfer learning and the learning on the own dataset. So first of all, here are my results for the SAE, the layout detection. I've got 328 sheet music. I've annotated 1028 staves, and the layout detection was able to identify 1208 true positives, 14 false positives, and an average intersection over union of 91.93%, and a F-score of 0.992. So that's a pretty reasonable results. I was pretty glad to obtain them. The results for the end-to-end recognition wasn't as good, so you can see here from the left to right with the different combinations of datasets that the best dataset was the Regensburger Liedblattsammlung plus the camera primus for my second architecture. To see what the architectures looks like, I would reference you to the paper or the Google Colab that's still up. So if you're interested in more details about the architecture, you can take a look at the paper or the Google Colab. All right, so that was my work done on the Regensburger Liedblattsammlung. Now I would be really happy to hear some feedback back from you. I know I'm not there. I'll leave you my email, and I would be happy to hear if you would go on. I know I'm done with my bachelor thesis now in the scope of this project, but the Regensburger Liedblattsammlung still needs to be digitized. So that's a bunch of data, 140,000 pages. And my SER score didn't look that great. So I finished with a 40% error rate. That's nothing that the Regensburger Liedblattsammlung would work with. So what could I have done better? What would be the next step to improve these results? Is there any technology that might work better in these circumstances? Let me know. I'm looking forward to your answers. And to this point, have fun at the workshop and hasta luego.